Hello everyone, in this video we are just going to establish UART serial transmission from RL78 by F14 series Renesas microcontroller. Let's get started. So now let us try to understand the schematic diagram that we are going to build with the help of this Renesas RL78 bar F14 series development board and the USB to TTL converter for testing the UART transmission and reception. So you can see this is the development board, and in this development board we just analyzed that the RX pin is connected to CN2 connector 7th pin and TX pin is available in the same connector CN2 5th pin. So we will be utilizing these two pins. So these two are the RX and TX of UART0 of the microcontroller that we are going to enable. And in addition to that, we are just going to utilize the ground right over here in the CN1 connector. So this is the common ground for the development board as well as the circuit. So this is available in CN1 connector pin number 43. So these three are the connections that we are going to make between development board, this development board and the USB to TTL converter. So you can clearly see the P15 is the TX pin of the microcontroller, that is UART0 TX pin, and P16 pin of the microcontroller is the UART RX pin. So we will be connecting the TX of the microcontroller to the RX of the TTL converter and RX of the microcontroller to TX of the TTL converter. So this is the USB to TTL converter. So this converter is useful for converting one level of voltage signal into another level, that is from the level of voltage signal from microcontroller level to PC USB level. So we will be utilizing this USB to TTL converter or USB to UART converter for transmitting and receiving data between PC serial terminal software and our microcontroller. So you can use any one of USB to TTL converter. So I will show you while I am connecting what is the type of TTL converter that I am using. And on the screen you can see this is the type of TTL converter that I am going to use in this video. So in this TTL converter I will be connecting the mini USB cable from this TTL converter to the PC USB port, and in the other end of the TTL converter I will be connecting the ground of the TTL converter to the ground of the development board, and TX of the TTL converter will be connected to RX of the microcontroller UART port. So UART0 RX pin is P16. So I will be connecting the RX pin of the microcontroller to the TX pin of the TTL converter, and RX pin of this converter will be connected to TX pin of the microcontroller UART port. So UART0 port pin of the microcontroller is available in the CN2 pin number 5, that is P15. So this TX pin of the microcontroller will be connected to RX pin of the TTL converter. So that's all about the circuit that I'm going to make between the development board and the USB to TTL converter for establishing the UART communication between these two, that is between the serial terminal software in the PC and the microcontroller RL78 bar F14. So I hope you understood the circuit connections. So let's see how we can configure this UART further in the microcontroller and how we can transmit some byte of data through the UART serial port of the microcontroller. So now let us try to open the CubeSuite Plus for CCRL IDE for creating our project for the microcontroller. You can see in this IDE opened, I'm just going to create my new project. Just click on the project tab in the top of the window and then hover over this create new project and click on it for creating your new project. And in the window that is popping out, just type in the microcontroller name. In my case I'm just typing R5F10PPJ, and you can see the highlighted microcontroller will be selected by default. So just cross verify that the pin number is correct for your microcontroller. In my case it is 100 pin, it is correct, so I'm just leaving it. Or if it is anything different like this one or this one, just click on select anything as per your requirement. Just left click and select it as per your requirement. And once after selecting the microcontroller, just provide a name for your project in this project name tab. I'm just providing it to be Pro. And in place of this place tab, just click on this browse button for selecting the repository or directory in your local folders where you want the project to be stored. So let me just make a folder right over here, RL78, and I'm selecting that folder and I'm clicking on the create button for creating my project for this particular microcontroller selected. You can see on the left of the IDE we are having a particular tab called project tree. So this particular tab will be containing several segments of the microcontroller. Those are very important. First and foremost segment is the pin configurator segment, and next segment is the code generator segment, and the next segment is the file segment. So these three are the major segments that is generated for your microcontroller. So this pin configurator segment is useful for visualizing the configurations that has been done for your particular microcontroller. So when I double click on this device top view, you can clearly see this is the layout diagram of my microcontroller RL78 bar F14, that is R5F10 PPJ. You can see each pin description has been provided right over here. Once the configurations is done, you can see the configurations that has been done as a whole in this layout. So for that purpose, this pin configurator has been provided. So using this code generator segment right over here, you will be able to generate your own base peripheral software that is required for your microcontroller as per your user application. So I will be showing you how to configure your microcontroller in a while as per your application needs. But before that, we just want to do some basic configurations that needs to be done for almost all the programs. Just double click on this clock generator tab inside the code generator and you can see these configurations, that is the default configurations that needs to be fixed in the microcontroller before moving on. So let's take an example. This particular PIOR00 is yet to be assigned to the function TI00 and the respective port pin for that function is P17 by default. So if you need any alternate port pin to be configured for this function, let's check it out. Just click on this drop down. You can see the alternate pin that can be assigned with the same function is P66. So if you want that particular pin to have this feature, you just want to select that. So most often we will not be changing anything right over here. We can use all these functions for all these pins as it is. So if in case anything is required, I will just intimate you in future lecture videos. But for now, we will be fixing these settings by default. Just click on fix settings for fixing these settings as default settings in this microcontroller. Once that is done, just click on chip debug settings tab right over here. And this is a tab which is useful for enabling the debug option in your microcontroller. So if this is disabled, you will not be able to program your microcontroller using debugger, or you will not be able to debug your microcontroller using debuggers like E1, E2, E2 Lite, etc. So for that, just click on used radio button right over here. In my case, I'm just going to select the E1 right over here. If you are using any other emulators like E2 or E2 Lite, you just want to select the respective radio buttons right over here. So in my case, I'm just leaving this to be E1 selected. That's all about the basic configurations that you want to do. In addition to that, just double click on this watchdog timer right over here in the project tree inside the code generator, and you can see by default this watchdog timer is enabled or it is used by the code generator. So you just want to disable it. So I will teach you what is this watchdog and how to configure this watchdog in this microcontroller in a separate video. And for now, for almost all the videos, I will be disabling this watchdog, and in a separate video we will learn how to enable the watchdog and how to utilize its features for safeguarding our microcontroller. That's it. These are all the required basic configurations that you want to do for almost all the programs. So now let's just move for configuring our microcontroller as per our application needs. So after the basic configurations that has been done, I just want to configure the UART port of the microcontroller. So just double click on the serial right over here in the project tree, and you can see there are two channels, channel 0 and channel 1. And when you click on this drop down unused, you can clearly see you can configure this channel 0 as UART 0 channel, SPI 0 channel and I2C 0 channel. So I am just going to select UART 0 channel, and here in the next drop down that is popping out, just select the respective type of channel. So if you select receive function, then this particular channel will be only able to receive UART data through this UART 0 channel. And if I select transmit function right over here, then the UART channel that you are configuring right over here, that is the UART 0 channel, will be capable of only transmitting and it cannot receive the UART data. So I am just going to select transmit bar receive function, so that this channel will be capable of performing transmission through UART as well as reception of data through UART. And then click on the UART 0 tab that has been enabled once you configure a particular channel as UART 0 right over here. You can see the data length settings is set to 8 bits. So the byte of data that we are going to transmit through the UART is 8 bits. Whether it is transmitted or received, we will be transmitting only 8 bits at a time. So I am just leaving this, and transfer direction settings will be set to LSB only. So this is default settings. So priority setting is none, and receive data level setting is normal, and the baud rate, this is very important. So as per the requirement you have in your communication, you just want to select the baud rate. So I am just selecting 9600. If you want a higher rate, you just want to select the respective baud rates, whether it could be 19200, 31250, 38400, etc., 76800, and it goes on like this. I am just going to select the minimum baud rate, that is 9600. And when you click on these two check boxes, it will enable the reception end callbacks and reception end error. And inside this tab right over here, there is a tab called transmit. So this particular tab that I was discussing so far is for the reception part of the UART channel, and this particular tab is meant for transmission part. So here also you can leave it as it is. You can leave the single mode transition as it is, and data length is set to 8 bits. It is okay. And direction transfer settings is also LSB. Priority is none, 1 bit, and the transmission baud rate is 9600. And here also you can enable the transmission end callback. So this particular callback functions for transmission and reception is very useful in case you want to check whether the communication is properly happening in your program. So that I will explain a little later in this same video while we are programming the microcontroller. So for now, just leave all these settings, properly set the baud rate and the data length right over here in this tab as per your requirement, and then click on generate code for generating the base driver required for the project. So we are just going to perform only the UART transmission through UART 0 port of the microcontroller. So to find the respective pins that is required for transmitting and receiving the data through UART channel that you are configuring, just select the UART 0 right over here, just open this UART 0 tab and double click on this device top view. Now after coming to this top view, just come to this code generator and go to the channel and then return back to this UART 0. Just hover over this UART 0 again and come back to UART 0, and when you move to the device top view, you can clearly see there will be two pins highlighted. One is the P15 and another one is P16. So this P15, you can clearly see this is the TXD0, that is the transmission pin of UART 0, and this P16 is the RXT0, which is the reception pin of the UART 0. So you can utilize these two pins for transmitting and receiving data through UART 0 of the microcontroller. So I am just closing this. So this is how you can find the respective pins for any pin configuration that you are doing. You can use this device top view for finding the respective pins. Now that the base drivers are generated, let me just open the code for writing down the logic for transmitting a byte of data through UART 0 port of the microcontroller. Now I am just going to open the main.c file. You can clearly see this is the main.c file, and you can additionally see there are two different files that has been generated, that is the serial.c and serial user.c. Just open the serial.c and serial.h. So in this .h you can see the respective function declarations which you can utilize for establishing UART communication in your microcontroller. So mainly there are two functions that we will be utilizing for establishing UART transmission through UART 0 port of the microcontroller. One is the RUART 0 start and another one is the RUART 0 send. So this particular function is useful for initializing the UART port or for starting the UART communication in your microcontroller, and this particular function right over here is useful for performing the UART transmission. So let me just copy this function declaration and let me just call it before while of 1 right over here. And one more thing is I'm just going to declare and define a rough delay function, that is the loop delay function, which we will be utilizing in this program. So this is just a rough delay, that is a loop delay function that you can use for generating rough delays in your program. So before initializing this UART 0 start, I am just going to produce a rough delay right over here. And after initializing the UART, I am just going to produce two same amount of delays, and after that I am just going to perform UART transmission. So as I mentioned, the function UART 0 send is useful for transmitting a byte of data or a certain bytes of data. So let me just copy this declaration, and here we just want to transmit two different parameters. One is the buffer containing the bytes to be transmitted, and another one is the number of bytes that you want to transmit from that particular buffer provided in the parameter 1. So this is the parameter 1. So let me just write tx buffer. I will declare and define this buffer in a while, and I am just going to transmit 1 byte of data from this tx buffer. So here I am just going to declare tx buffer of 1 is equal to character small a. Now I'm just going to compile this program. You can see the compilation is successful with 0 errors and 0 warnings. Now let us test the UART transmission whether it is functioning properly or not. So you can clearly see the program is very simple. We are just going to utilize only two functions from the serial base driver that has been generated from our code generator. One is the UART 0 start and another one is the UART 0 send. So this UART 0 start is useful for initializing and starting the UART 0 communication in your microcontroller, and this UART 0 send is useful for transmitting a byte or a certain number of bytes on the UART 0 serial terminal of the microcontroller, serial port of the microcontroller. So you just want to declare a 8-bit buffer right over here. You just want to provide a 8-bit buffer as the first parameter to this UART send function, and as a second parameter to this function you just want to provide the number of bytes that you want to transmit from the parameter 1 provided buffer. So tx buffer comma 1, which means tx buffer is the buffer which must be transmitted and the first byte of the tx buffer must be transmitted. So if I provide a value 2 right over here, the first byte of the buffer and the following second byte of the buffer will be transmitted in the UART 0 line. So that's it. So let me just compile this again. The compilation is successful. Since these lines are written inside the while of 1, and since the tx buffer is having the value character small a, the character small a will be repeatedly transmitted from the UART terminal of the microcontroller to the PC serial terminal software at a regular interval, that is regular rough interval, because I have provided a certain rough delays right over here, and all these lines are written inside the while of 1, which is the infinite loop of the program. So for every rough delay of so and so written right over here, the character small a will be transmitted from the UART 0 port of the microcontroller to the serial terminal software in the PC through USB to TTL converter. So this is the basic functionality of this program, and just right click on this RL78 simulator and then hover over using debug tool and select the respective debugger. Now I'm just going to dump the program. Just click the F6 in the keyboard or this icon right over here. Now I'm just running this program. So you can see this is the USB to TTL converter that I am using for transmitting the data from my microcontroller to the PC serial terminal, and from the serial terminal of the PC to the microcontroller serial port. So this TTL converter will help us to convert the high level signal from the PC USB port to the microcontroller level signal. So in this terminals, we are just going to utilize only three terminals. One is the ground pin of this TTL converter, which is connected to the violet jumper wire, will be connected to the ground of the development board, that is the CN1 connector, pin number 43. You can clearly see here 49753. And other than that, the two terminals that we're going to utilize from this TTL converter is RX and TX. So RX is connected to gray wire and TX is connected to brown jumper wire. RX of this TTL converter will be connected to TX of the microcontroller, and TX of the TTL converter will be connected to RX of the microcontroller. So this particular RX, which is connected to gray jumper wire, is connected to TX of the microcontroller UART 0 port, that is the P15, and TX of this TTL converter, which is connected to brown jumper wire, is connected to RX of the microcontroller, that is the P16. TX pin of the microcontroller is nothing but P15, which is connected to CN2 pin number 5. So CN2 connector is right over here, and pin number 5 is 135. And RX pin of the microcontroller is nothing but P16, which is the CN2 pin number 7. So 1357. So right over here, we are utilizing RX and TX. Right over here, we are connecting RX and TX of the microcontroller to the RX, TX and RX of the TTL converter right over here. So that's all about the connections. TX of the TTL converter will connect to RX of the microcontroller, and RX of the TTL converter microcontroller will be connected to TX of the TTL converter. And then we are commonly sorting the ground of the TTL converter to the ground of the microcontroller right over here. So now we are completed with the logical part of the program, that is we just transmitted one character, that is character small a, using UART 0 transmission line of the microcontroller RL78 bar F14. And for every constant rough intervals of so and so delay right over here, we will get the character small a transmitted once. And since all these lines are available inside the while of 1 right over here, this happens continuously until the microcontroller is stopped. So until you stop the microcontroller or until the microcontroller is powered off, this operation will be held in the microcontroller. That is, for every constant rough delays of so and so right over here, we will get the character small a available in this TX buffer gets transmitted through UART 0 line of the microcontroller. So I'm just going to dump the program. Before dumping the program, right click on this RL78 bar F14 debug tool and hover over using debug tool and select the respective debug tool. In my case, I'm using E1 emulator, so I have selected E1 emulator. If you are using any other emulators like E2 or E2 Lite, just select the respective emulator for dumping the program. I'm just going to click on this icon, or you can also click F6 in the keyboard for dumping the program. Now I'm removing all the breakpoints. Now I'm just going to open the serial monitor software that I'm going to use, that is the Docklight. You can use any software, any serial terminal software if you want, but I'm just using it because I got used to this software for many times. So just double click on this top right corner COM and select the respective COM device. So in my case, I'm having COM3 connected, that we connected already, that is the TTL to USB to TTL converter has been connected from USB port of the PC to the microcontroller serial port, and baud rate is 9600. We set that and click on OK. Now for starting the communication, just click on the start communication icon right over here in the left top corner. You can see the communication is started in this Docklight software. Now when I start the program right over here, Now when I start the program right over here and go to the dock light, you can see the character A is being transmitted at a constant rough delays between each transmission. So as per our expectation, the UART transmission is working fine. So we successfully transmitted a byte of data using UART serial transmission in our microcontroller RL78 bar F14. So now let us try to add a check to our program to check whether the transmission which is happening right over here is properly completed in our UART serial port. So we successfully transmitted a byte of data, that is character small a, from our UART 0 port of the microcontroller to the serial terminal software, that is docklight, available in our PC through USB to TTL converter continuously at a certain rough intervals of time. So now we are just going to alter the same program with high accuracy, or we can say it to be with high protective measures. So what we are going to do is we are just going to move to the serial user.c that will be generated along with the base driver with the help of code generator when you click on the generate code button. So scroll down a little bit and here you can see there is an callback function called UART0 callback send end. So this particular callback or interrupt function is useful for indicating that the transmission is complete. So let me just write down one line of code, that is a is equal to 1. So I'm just going to declare this variable as global variable to this file. So uint 8 underscore t a is equal to 0, and I'm copying this and moving to the main function. I'm just going to extend the same variable scope to this main.c file. Now when I compile, you can see the compilation is successful. So what we are going to do is we are just going to add protective border for the UART transmission, or we are just going to add a check in our program whether the UART transmission is successfully completed. So let's assume we are just transmitting a byte of data right over here, and following this I'm just going to transmit again the same data. So in this case, just assume that after successful transmission of this data from the buffer of the microcontroller, there could be some mistakes happening inside the registers of the microcontroller, or there could be some errors caused in the timings of the microcontroller or timings in the UART peripheral of the microcontroller. So that could lead or that could affect the second transmission operation right over here below the first transmission operation. So to avoid this, you can utilize the callback function that is available right over here. So whenever a successful transmission happens in the UART port of the microcontroller, this function will be called once and it will be executed once after every successful byte transmitted in UART communication. So now I have written a line called a is equal to 1, that is I have made the variable a to be 1 right over here inside the callback, which means for every successful byte that is transmitted, this variable, that is the global variable a, will be made with the value 1 or will be assigned with the value 1. So I can add, like, I'm removing that line and I'm adding, after transmitting it, I can add while of a equal to 0. And above this UART send, I am just going to add a is equal to 0. So now you can clearly see here we are voluntarily making the global variable a from that serial user.c file to be 0, and we are transmitting the data. So as I mentioned, for every transmission or after every successful byte transmission in UART port of the microcontroller, that is UART 0 port of the microcontroller, this callback function or interrupt subroutine function will be called once and it will be executed once. So here we are making the same variable to be 1. So after transmission of this data, this loop will hold the control of the program until the a value becomes 0, a value becomes 1. So you can clearly see while of a equal to 0. So until the a value is having the value 0, this loop will never be skipped, because we have made the a value to be 0 right over here. Until and unless this function is executed, it will never become 1. So after successful transmission, when the callback function is executed, this variable value will become 1 and this condition right over here will be failed, because the a variable is made 1 in that callback. So this loop will be skipped and the control goes over to this first line inside the while of 1, that is to this delay function call. So the same operation, that is the character small a, will be transmitted at a rough delay intervals, rough equal delay intervals from the UART port of the microcontroller to the docklight serial software. But this time we have added a check that without proper transmission of a byte of data, we will not be moving to the next transmission of byte of data in the UART port of the microcontroller. So this is how you can utilize this interrupt callback functions of UART send end for properly transmitting a byte of data from your microcontroller. So I'm just compiling this program. You can see the compilation is successful with 0 errors and 0 warning. So now let us try to dump this program to the RL78 by F14 series microcontroller. So before dumping the program, just right click on this RL78 debug tool option in the left project tree tab and hover over using debug tool and select the respective debugger that you are using. I'm using event debugger, so I have just selected the event debugger. So if in case you are using any other debugger like E2, E2 Lite, etc., just select that respective debugger which you want to use for dump the program to the microcontroller. Now click on this icon right over here or F6 in the keyboard for dumping the flash or the program to the microcontroller. So as per our program, we are just initializing or starting the UART 0 communication right over here before the while of 1, and inside the while of 1 we are just producing 2 delays, and after 2 delays we are making the a variable to be holding the value 0, and after that we are just transmitting the variable tx buffer of length 1, that is we are just transmitting only 1 byte of data that is available as the first element of tx buffer using UART 0 transmission, and after that we are waiting for this particular variable to go beyond the value 0, and if it is 0, this loop right over here will be skipped. So this while of a equal to 0 will be true until the a variable is having the value 0, and if it is beyond 0 or if this value is not equal to 0, this condition will fail and this loop will be skipped. So once this loop is skipped, the control automatically goes to this line, that is the first line of the while of 1, because this is a while of 1, which is an infinite loop. So after executing all the lines inside this loop, the loop again comes to the beginning of the loop and continues the execution. So this is what happens inside this while of 1, which is the infinite loop. So when this value of a variable will become 1, that is coming to the ISR function, that is the callback send end function inside the serial user.c. You can clearly see this is the interrupt function for UART transmission. So once a UART transmission is successful, you will get this callback function for called once. So once after completing a byte of transmission successfully in UART 0 transmission line, this callback function or interrupt subroutine function or interrupt service routine function will be called once. So once it is called, we are just voluntarily making the a variable to be 1 right over here. So this a variable is declared and defined right over here, uint8 of a, and it has been extended to this main function right over here. You can clearly see the same variable. I am just extending the scope from that serial user.c to this main.c. So I'm just using and checking the same a variable right over here using this while of 1 until it becomes the value 1. So when it reaches the value 1, it means the transmission is successful. Once the transmission is successful, we are leaving this while of equal to 0, and we are moving to the next statement, that is to the beginning of the same line. So before transmission, we are voluntarily making the a variable to be 0. So for successful transmission, we are just doing this. We are just making the a variable value to be 0, and we are transmitting the data, and we are waiting until the send end callback or send end interrupt function is executed, which means we are just waiting until the transmission is successful in UART 0 transmission line using this while of a equal to 0. So now I'm just going to open the Docklite software. Double click on this right top corner, that is COM, and select the respective COMs. You can clearly see I'm having COM3 to which the USB serial port is connected. So we just already connected the TTL converter from microcontroller serial port to the PC through mini USB cable. So click on OK. Now I'm just clicking on the start communication icon in the left top corner of this window. So now this Docklite software is ready for receiving the data. Now I'm just going to click on the play button. Once the play button is clicked, our expectation is very simple. The a variable or the character a, which is stored in the tx buffer, will be keep on transmitted from the UART 0 line of the microcontroller at a certain constant delay intervals of rough delays of so and so. You can clearly see rough delays of 10 lakh and 10 lakh. For every 20 lakh rough delays, we will get the character small a being transmitted from the UART 0 line. So when I click on the play button, you can clearly see as per our expectation, we are getting the output, that is the character small a is being transmitted from the UART 0 line of the microcontroller RL78 bar F14. So now let us try to analyze how the variable a value is becoming 1. So I'm just going to keep the breakpoint right over here in the line of a equal to 0 and right over here in the first line of delay, so that I will check for a equal to 1 before it becomes 0. Equal to 0, and I will keep the breakpoint right over here before after transmission of the data. So I can clearly see in this position, I'm just going to add this variable to watch window just right click on this variable and select register to watch 1 and right click on this and hover over notations and select signed or unsigned decimal. You can see the a variable is having the value 1. So when I click on this play button again, the control will go to the while of a equal to 0. You can see while of a equal to 0. So after successful transmission, we are having the value a equal to 0 because we are making the a variable value to be 0 before transmission. So once after successful transmission of byte of data, this a variable will become 1. That is our expectation, because in the callback function right over here, we are making the a variable value to be 1. So when I click on the play button again, you can see the a variable value has become 1. Oh, so which means the a variable value is made 1 after successful transmission of data in the interrupt subroutine function of transmission end. So this function is called successfully, that is why the a variable value has become 1. So when I click on the play button again, you can see the loop continues and it has arrived inside the a equal to 0 line. It has arrived to the a equal to 0 line. So now let me just try to keep a breakpoint inside the interrupt subroutine function. So I'm just going to check whether the control comes to this interrupt subroutine function after the transmission of data. So the while of a equal to 0 line has arrived, and when I click on the play button, you can see the control comes to the callback function of send end. Again, when I click on the play button, the process continues. A becomes 1 and it comes to the a equal to 0 line. A becomes 0 and it reaches the while of loop and it reaches the callback again, and here it becomes 1 and again comes to the check condition and it will skip this loop. A becomes 0, transmitted, checks for the transmission complete, it comes to the callback, becomes 1 here, again comes to the check and it continues. So this is how you can add a checkpoint for checking whether the transmission is properly completed inside the UART transmission. So I hope you learned the method or way of transmitting properly a byte of data using UART communication in this RL78 bar F14 series microcontroller. See you in the next video. Thanks for watching.